Hello guys, my name is Rekha Yadav and my presentation topic is instrumentation of HPLC. So before we go into the main topic, I would like to explain what is HPLC, their types and in which principle HPLC works. So first one is introduction. High performance liquid chromatography HPLC, formerly referred to as high pressure liquid chromatography, is a technique in analytical chemistry used to separate, identify and quantify each component in a mixture. It relies on a pumps to pass a pressurized liquid solvent containing the sample mixture through a column filled with a solid adsorbent material. Each component in the sample interacts slightly different with the adsorbent material, causing different flow rates for the different components and leading to the separation of the components as they flow out of the column. Their types. First one is normal phase HPLC. This method separates analytes on the basis of polarity. Non-normal phase HPLC uses polar stationary phase and non-polar mobile phase. Therefore, the stationary phase is usually silica and typical mobile phases are hexane, methylene, chloride, chloroform, diethyl ether and mixture of these. Polar sample are thus written on the polar surface of the column packing longer than less polar materials. Second one is reverse phase HPLC. The stationary phase is non-polar in nature while the mobile phase is a polar liquid, such as mixture of water and methanol of acetonitrile. It works on the principle of hydrophobic interaction, hence the more non-polar the material is, the longer it will be written. Third one is size exclusion HPLC. The column is filled with material having precisely controlled pore sizes and the particles are separated according to their molecular size. Larger molecules are rapidly washed through the column. Smaller molecules penetrate inside the pores of the packing particles and elute later. Fourth one is ion exchange HPLC. The stationary phase has an ionically charged surface of opposite charge to the sample ions. This technique is used almost exclusively with ionic or ionizable samples. The stronger the charge on the sample, the stronger it will be attracted to the ionic surface and thus the longer it will take to elute. The mobile phase is an aqueous buffer where both pH and ionic strength are used to control elution time. Principle of HPLC. The separation principle of HPLC is based on the distribution of analyte between a mobile phase and a stationary phase. Depending on the chemical structure of analyte, the molecules are retarded while passing the stationary phase. The specific intermolecular interaction between the molecules of a sample and the packing material define their own column. So hence, different constituents of a sample are eluted at different times. Thereby, the separation of the sample ingredients is achieved. So an detection unit recognizes the analyte after leaving the column. The signals are converted and recorded by a data management system and then shown in a chromatogram. So, instrumentation of HPLC. HPLC instruments consist of following component. First one is solvent reservoir, second one pump, third one sample injector, fourth columns, fifth detector and sixth data collection devices. So first one solvent reservoir. So mobile phase contains are contained in a glass reservoir. The mobile phase or solvent in HPLC is usually a mixture of polar and non-polar liquid components whose respective concentration are varied depending on the composition of the sample. Second one, pump. An HPLC pumping system has the following stringent requirements. First one is generation of pressure of up to 6000 psi. Second, pulse free output. Third, flow rates range from zero point 0.1 to 10 milliliter per minute. Good flow control to provide flow reproducibility of 0.5% or better. Fourth, corrosion resistant components. There are three main types of HPLC pump. First one is reciprocating pump. So solvent is pumped back and forth by a motor driven piston. So two ball check valves which open and close, which is used to control the flow of solvent. It has the same small internal volume 35 to 400 microliter. It gives high output pressure up to 10,000 psi. It gives constant flow rate. Second was displacement pump. It consists of large syringe-like chamber equipped with a plunger activated by a screw-driven mechanism powered by a stepping motor. It is also called as screw-driven syringe type pump. Advantage: it produces a flow that tends to be independent of viscosity and back pressure. It also has disadvantages. It has limited solvent capacity and considerably inconvenient when solvent must be changed. Third one is pneumatic pump. In this pump, the mobile phase is driven through the column with the use of pressure produced from the gas cylinder. It has limited capacity of solvent. Third one, sample injector. The injector can be single injection or an automated injection system. An injector for an HPLC system should provide injection of the liquid sample within the range of 0.1 to 100 milliliter of volume with high reproducibility and under high pressure up to 4000 psi. So injectors are used to provide constant volume injection of the sample into the mobile phase stream. Inertness and reproducibility of injection are necessary to maintain a high level of accuracy. Fourth one is column. So columns are usually made up of polished stainless steel, are between 50 and 300 nanometer long and have an internal diameter of between 2 and 5 millimeter. They are commonly filled with a stationary phase with a particle size of 3 to 10 micrometer. So column with internal diameter of less than 2 millimeter are often referred to as microbes column. Okay. So fifth one is detector. The HPLC detector located at the end of the column detect the analytes as they elute from the chromatographic column. Commonly used detectors are UV spectroscopic, fluorescence, mass spectrometric, and electrochemical detector. Data collection devices. So signal from the detector may be collected on chart recorders or electronic integrators that vary in complexity and in their ability to process, store, and reprocess chromatographic data. The computer integrates the response of the detector to each component and places it into a chromatograph that is easy to read and interpret. Thank you.